Hi, today we're going to talk a little bit more about confidence intervals. I've written the two forms of confidence intervals above, and they differ just slightly. In fact, the only difference between these two formulas is this thing called z sub alpha over 2 versus t with n minus 1 degrees of freedom of alpha over 2. The difference being how these two numbers are calculated. One comes from a normal distribution, one comes from a t-distribution. And if you're wondering when to use each of these, well, the formula here has a population standard deviation. So to use this formula, we need the population standard deviation, a value of the population. The bottom one uses a t-distribution, but it has an estimate of the standard deviation coming from the sample standard deviation. So the question is, if we want to know which formula to use, we need to know, are we given a population estimate or are we calculating the sample standard deviation? Well, let's look at the example below here. So here we have n being 36 observations, and we have taken 36 individuals to determine the number of days of leaves employees take at a specific company. It's found that the average number of days of leave is 9. And from historical data, so this all gets logged in HR, we calculate the population standard deviation from previous data, from like last year or from several years ago, and we determine sigma is 3. Because I'm giving an estimate of the population standard deviation from historical data, I'm given a value of the population standard deviation to use. So let's answer the first question, and we're just going to use this formula, x bar plus or minus z of alpha over 2 times sigma over root n. If we plug in the given information, we know that x bar is 9. We add and subtract this z sub alpha over 2 times by the sigma, which is 3, divided by root 36. The only thing left to do is to calculate z sub alpha over 2. Where does that come from? Well, you could use the table in a textbook. You could use a statistical computing software such as R or Python. You can also use an online calculator. And today we're going to focus on an online calculator. So let's go to this online calculator. This one's called the inverse normal distribution, and this comes from David Lane, who wrote the textbook Online Stats book, which you're welcome to use that calculator. Right now, I want a 95% confidence interval, so I'm going to put 0.95 for the area. And I want this to be between, not above or below. This is very important. And the numbers I get are minus 1.96 and positive 1.96. So this information is very important. You'll notice that it shaded the middle. 95% corresponds to the area between minus 1.96, almost minus 2 on this graph, and positive 1.96. That's the 95%. it's very important that the mean be 0 and standard deviation be 1. And if you're going to put 0.95, you have to put the between. You could also do above or below, but then you'd have to put 2.5%. The 2.5% comes from 1 minus alpha over 2. So if I take 0.95, I subtract 1 from it, that's 5%. Then I do alpha over 2, that's 2.5%, and that'd be in this tail. So let's do that. If I want to do the above here, to find the confidence interval, I would do, well, for a 95%, that means 5% outside, but divide it by 2 because there's 2 tails. So 0.025. Okay, and 1.6449. So very, very much the same. Let's go back to being between, where I can do just enter the 0.95 and minus 1.96. The numbers are just slightly rounded because of the specificity here. I'm going to go with 1.96 here, and we're going to use that number. Okay, so now let's enter this and calculate it. So we have 9 plus or minus 1.96 times 3 divided by 6. I get 9.98. So that is the upper value. The lower value we just have to subtract. And I get 8.02. So if I was asked for the confidence interval for the average number of sick days at a 95% confidence interval, it'd be 8.02 to 9.98, so about 8 days to 10 days is how many days of leave an average employee takes with 95% confidence. Okay. Now, 2, now I should probably just revise this confidence interval. The interpretation, that's how a lot of people say it, the interpretation is that the mean is contained, the true population mean is contained somewhere between 8.02 and 9.98. We don't know exactly if it's 8.02 or 9.98. And the emphasis here being the distinction between what I just said, which is the most common interpretation, is that the population mean is not viewed as a random variable, so it's not a random variable between two values, but it's contained in the interval, and that is the most accurate statistical explanation. The most commonly used business explanation would be that it's somewhere between these two values. Okay, so just a small distinction. Now, if I want to do a 98% confidence interval, the only thing that's going to change is the number that we put there. So we have to go back to our calculator. Instead of putting 95%, I need to put 98%. So here, I need to change this from 0.95 to 0.98. And I get 2.32. And you could do the 6 if you wanted, 2.326. So let's enter that number. And let's see what we get. So on a low, we'll get 7.83. 0.37. On the high, we get 10.16 days. And 10.163. So that would be for a 98% confidence interval. And this one would be for a 95% confidence interval. Okay, and that was just two examples of using an online calculator to calculate a confidence interval. Thank you very much.